Today we're going to talk about writing equations and inequalities, okay? So again, this is a focus on writing. We have already learned how to solve equations, and we will learn how to solve inequalities later this week. So today we're going to talk about writing. So writing specifically involves a focus on vocabulary, okay? We're going to focus on the vocabulary we see in these word problems, okay? And this is a pretty comprehensive list of everything that you're gonna see on your STAR DCP. So these are words that mean add, this top section, okay? These are common words that mean to add. Again, these are common words that mean to subtract, the common words that mean to multiply and divide, and then these symbols right here are these words right here, okay? These two are combined because this line right here is equal to, and you're going to have that line if you see the word at, like at least or at most. If you see the word or more, or less. If you see the word no more, or no less. If you see the word maximum or minimum. So again, these words at or no, maximum or minimum are going to mean that our inequality sign also has the equal sign underneath, okay? So just some things to remember, and this is going to be a good reference in the future as we work through these problems. Okay, so we're going to open our notes, and we're going to start with writing equations. Okay, again, just to focus on vocabulary, but we're going to start with equations. Remember, equations have an equal sign, or the word is. Okay, so when using a strip diagram, the total always goes on the bottom. So that's not new information for us. The total always goes on the bottom, okay? Again, not new information for us. So this is our strip diagram. I'm going to show you what to do. So this is just to help us create an equation. Remember, we're writing equations. So it says, Ty went to the store and bought a video game for $35 and a controller. He spent $63 at the store, and they want to know write an equation where X is the cost of the controller, okay? So important information, he bought a video game for $35 and a controller. So and meaning we're putting these two things together, okay? And video game and controller. Okay, and then it says he spent $63. So that is our total. All right, so we are going to set that up into our strip diagram here. So we're going to divide it in half. Okay, remember the bottom is going to be our total. We know our total was $63, right? We know that because they said the word spent, okay? He spent $63, that's our total, and it goes on the bottom, okay? What makes up that total? Well, we had two things. We had a video game, so I'm gonna write game, and it was $35. And we have a controller. We do not know how much the controller cost, so I'm gonna write controller. And again, they want us that to be letter X. So I'm just going to put an X. Okay? And so now I'm going to create an equation. So all I'm going to do is I'm going to write what I drew here. So I know that I could have my video game and, right, plus and my controller. Controller was X. And that total is going to be $63. Again, you could reverse that. You could put the X in front, and that's not going to change it in any way. You could also write it as a subtraction problem. 63 take away your game equals your controller. Okay? So either one of these would be the correct equation for this problem because you are adding your controller and your video game together to equal the total, or you're taking your total and you're getting rid of your video game to find your controller, okay? So those are the two ways we might see this equation. So let's try the next one. The next one says, John was gifted a pack of crayons. He gave 13 crayons to his friend Rhea and was left with 11 crayons. Write an equation to find out how many crayons C the pack contained. Okay, so we're going to start and we're going to say, do we know our total? Well, it looks like C is our total and it's missing. Okay, but total still goes on the bottom. Okay, and again, that was letter C. Okay, and so again, missing, but that's okay. I'm going to label it with the C. So up top, we have he gave 13 crayons. He gave 13. And he was left, so again, and is a good plus word. And he was left with 11. So he gave these away. He had these left. Together, they make our total crayons. So I'm going to create my equations here. The first one I could make is just the 13 that he gave away plus the 11 that he still has equals my total, right? Or I could say, okay, my total take away the 11 he still has equals the 13 he gave away. Or you could even reverse that and say the total take away the 13 he gave away, and that leaves him with 11. So if you had answer choices, any of these might be a good answer, a good equation to represent this situation, because we have words like gave, left, and then of course and, this and that. Okay, those all are going to equal some sort of adding and subtracting equation. Okay, all right, adding and subtracting only. There's no multiplying or dividing words in this problem. Same as this one, there was no multiplying or dividing words. All right, example number 3. Mr. Castle paid D dollars for each of the 4 bags of chips he bought at a local store. He spent $14 at the store. Write an equation that best represents D, the amount of each bag. So D, the amount of each bag. He spent 14, and that is our total. And he bought 4 bags. Okay? So I'm going to put my total on the bottom of my strip diagram. That's how much he spent in all. Okay, he spent $14. All right, and then up top, he bought 4 bags of chips. So the bags each represent the letter D. Okay, so this bag of chips, this bag of chips, this bag of chips, this. So there's his 4 bags, 1, 2, 3, 4, but we don't know the cost of them. We don't know how much they cost. So we know together they equal that $14. So again, we had total on the bottom. We had 4 sections. Each section is a bag of chips. So let's talk equations. Well, we know that it says each, and each is a good multiplying or dividing word, so that's that vocabulary we're looking for. Okay, we have our total. That's good vocabulary. Again, each up here again, good multiplying and dividing word. So the way to decide on this is if it says each, but you know the total, that's probably a division problem. So we're going to start with our division. Our $14 divided by our 4 bags equals the cost of each bag. You could also say 4 bags times the cost of 1 equals 14. Okay? And remember, this is like saying 14 over 4 equals D. So these are the same thing. Remember, a fraction always represents division. All right. And then we're going to scoot on down. So now we're kind of looking at the opposite. Now they give us the equation, and we have to figure out which of these words matches it. Okay, so I'm going to read through. It says, which statement could be represented by 8x equals 304? So I'm looking for a total of 304. and I'm looking for multiplying words. Okay, so looking for multiplying vocabulary, because I know that when a number and a letter sit next to each other, it means to multiply. All right, so Megan is creating a YouTube playlist and she needs 304 minutes. So that matches our total. She currently has 8 minutes. How many more? Well, hopefully at this point you guys know how many more is really an add or a subtract word. So that's not the multiplying words we're looking for. So we're going to move on to the next answer choice. Letter B, a car wash profits $8 on each car. So each is a good multiplying and dividing word. It says the car wash earns 304, and again, that's our total. And it says on a premium wash, how many cars chose the premium wash today? So this has the multiplying we're looking for, and it has the total of 304. So I think that's a pretty good answer, but I'm going to put a question mark and keep reading. All right, letter C says Julie is separating a box of beads into 8 different bags. So I know that the word separating normally means division. So separating into, that's normally a dividing word. It also has the word each, so again, that's multiplying or dividing. And she receives, or each bag receives 304. Okay, so this one is more division because it says the word separating. And so I don't think this is as good an answer as letter B. Again, each bag receives 304. So that would mean we have a total divided by 8 bags equals 304 in each bag. So we know that's not correct because we're looking for multiplying to get 304. All right, and then letter D says she must sell 304 baseball cards. She has already sold 8. And it's going to say that how many more again, which we know is an add or subtract. So not a good multiplying word. So our best answer is in fact B, that one that we originally found. And that is writing equations. So now let's talk writing inequalities, okay? So these are our inequality symbols up here. We have our greater than, less than. Oh, looks like our box is missing our greater than or equal to, which is fine. That's not a big deal because it's also on the front, okay? Greater than, more than, greater than or equal to, no big deal, okay? But just know there should be another symbol here going the other direction. That is more than, is more, okay? Or equal. Okay, so that's missing, no big deal. All right, so writing inequalities. The first thing we're gonna do is we're gonna identify the keyword. We're gonna identify the operation that goes with that keyword, and we're gonna define our variable. So is it an X? Is it an M? Is it a T for Turner? And then we're gonna write our inequality, okay? So the first one says the sum of a number and 3 is no more than 8. The sum of a number and 3 is no more than 8. So I'm just going to break that whole sentence down. So the first word I see is sum. Sum means to add. And then a number, I'm going to call a number n. And then it says and 3. And then it says is no more than 8. So no more than looks like this. And you could test it. So I'm going to show you what I mean by test it. So again, we're going to write our problem in the sum 3 and then no more than 8. So I'm just going to come up with a number that's not more than 8. So I'm going to say 5. So over here to the side, I'm going to say 5 and 8. Which one gets eaten? The 8. Okay, so my symbol is in the correct position because it needs to be eating the 8. If something is not more than 8, it needs to be eating that 8. Okay? So again, no more than 8, there's that one. All right, and we're just gonna keep going. So we have difference. Difference means to subtract. Again, number n and 4. And then it says is at least 10. So again, that one n minus 4, and then at least 10. If you wanted to check your symbol, you could do that off to the side. The next one we have the maximum. That's one of our equality words. Maximum of number of students who can fit in one bus is 45. So I'm going to say my students is 45 is S, and then 45, and then again maximum, that means 45 is the most that we can get, so we need that equality line, and there's no adding or subtracting there. And then our last one, she wants to sell more than 10, okay, boxes of cookies. So the cookies has to be more than 10, not equal to 10, but more than 10. So you could plug in numbers like 12, 15. Okay, that Pac-Man is going to eat that bigger number. All right, and then the last part is graphing. Graphing's at the bottom down here. And so that one's pretty simple. If your dot is shaded in, you are going to have the equality line. Okay, so these two will have that equality line because the dot is shaded in. Okay, and then you're just going to trace your arrow. So my arrow looks like that. So my symbol will make that same shape. Okay, same thing here. This arrow looks like that. So that's what my symbol will look like. So essentially the arrow at the end of our graph makes the symbol that that goes with that problem. Again, these have the equality line because they're shaded in. All right, and then the last two will not have the equality line because they are open circles, they're unshaded, but they still follow the arrow rule. So this arrow looks like that. So my Pac-Man does that same thing. This arrow looks like that. And again, that symbol goes that direction. So that's our graphing. Again, shaded in makes the equality line, not shaded, no equal line. And that's writing equations, guys.